We are starting chapter 7, and it's all about trig stuff. All right, we talked about radians and the unit circle and our different functions for cosine, sine, and we found numerical values. Today we're going to start trigonometric proofs. Remember proofs in geometry when you had to like two-column proof? It's the same thing, same concept, but you're using trig functions.
Do we have to write?
You'll see. Okay, so guys, look. Here we go. An equation is a statement that two mathematical expressions are the same, right? X plus 2 equals 5. What does x equal? 3, right? X plus 1 squared equals x squared plus 2x plus 1. How'd they get that? You wrote it out, you expanded it. You wrote x plus 1, you FOILed it out. Algebraically. Okay, we're going to think algebraically today. You're going to prove these identities using trig identities, and you'll see in a second. But you're going to think algebraically. If you add or subtract fractions, you have to have a common what? Denominator. Okay, common denominator. If you have a 4 in the numerator of a fraction and a 4 in the denominator of another fraction, we can cross them out, right? Okay, we're going to use our algebraic concepts to simplify and to prove trig identities. This is a mathematical fact right here, that the sine squared of an angle plus the cosine squared of an angle equals 1. That is a fact. You don't have to prove it or anything like that. That is a fact. That's an identity, okay? What we're going to do is we're going to take a list of identities, and you will be provided these on any test or quiz. You do not have to memorize any of this stuff. I will give you a sheet of paper that has all this information on it. But we're going to prove that something is equal to something else just by changing its form. We're simplifying. We are not changing the value of anything. We're just changing the way it looks. So here at the top, and again, just follow along with me, we have our reciprocal identities. You need to become familiar with these. Again, you're going to get these on a test or a quiz. So if you see cosecant of an angle, what can I replace cosecant with? Cosecant is the same as what?
1 over sine.
What is cosecant the same at? Look at the identities. 1 over sine. What is cotangent the same as?
1 over tangent.
Or, no, cotangent. Look at it. It says 1 over tangent, or what else is it also the same as? Cosine over sine, all right? These two right here, you're going to use a whole bunch, because as we're simplifying, guys, what we need to remember, they're the two most basic trig functions are, I can't spell function, are sine and cosine. I'm going to say that 100 times. So when we're simplifying means make smaller. When you're simplifying, you always think in your mind, okay, fine. If I'm going to simplify this, I want to go to sines and cosines. I want to manipulate things. I want to change it. I'm not changing the value. I'm just changing what the words look like. Cosecant is the same as 1 over sine. If you can simplify and not have a fraction anymore, that'll be smaller, okay? And again, we'll talk about this as we go. These down here are called Pythagorean identities. What do you guys notice about these identities? Okay, good. I like that. There's an adding. Do you see how there's adding in them? So something is attached to something else. What else do you notice about them?
There's ones in all of them.
There's ones in all of them. Good. What's another thing you notice? The squared, right? When we think Pythagorean, immediately you guys go a squared plus b squared equals c squared, right? So when you're looking and you're trying to simplify, you're trying to make things smaller, and you see a trig function that is squared and has a 1 attached to it somehow, plus or minus, your eye should go to that part of our identities. And again, we'll go through these together, try to make a little more sense of this. Even odd cofunction identities, we're not going to get into much, so don't stress about this. Please, we're going to just focus right now on trying to make things a little smaller. All right, identities enable us to write the same expression in different ways, which is what I've been saying. All right, it says it's often possible to write complicated looking expressions in a much simpler version, which is what we're going to do right now. When we simplify algebraic expressions, guys, we factor, we get common denominators, we use special products. We're going to do the exact same thing here, but with words. All right? You guys okay with so far? All right, so here we go. This is a simplifying one. There's going to be two different kinds. We're going to simplify and we're going to prove. You'll know the difference by the next one I do because there's an equal sign. Personally, I think simplifying is harder than proving. You'll see why in a second. Because when you have to prove that one side is the same as the other, it kind of gives you a direction of what to go. But what we want to do is we want to simplify this expression. I don't want it to be so, it's got 3 different trig functions. I want to try and smush it all together. First thing I'm going to do is rewrite it because I don't like to use t's. Because what happens when Mrs. Meadows uses t's? It turns into plus signs. So I'm going to change, look, I'm changing all of the t's to just theta. If you want to change it to x's, you can. That's fine. So if we're going to simplify, guys, we're going to make smaller. I want to try and get rid of plus and minus signs. I want to try and go to, what are the 2 most basic trig functions we know? Sine and cosine. Okay, so let's just start out. And again, there's going to be some of these that you guys are like, how did you know how to do that? Well, I've been doing this for a long time, and it just takes practice. And the more you guys practice this, the more some of you this is just going to click because your brain works that way. Pablo, you were like this last year with this. But some people, this is going to be really difficult for you, and I understand that, and we're going to work on it. So if sine and cosine are our 2 most basic trig functions, do you have anything right now that has a squared on it that's attached to a plus or a minus 1? No. So I'm not going to, the first step, I'm not looking at the Pythagorean identities. Those aren't going to help us. So cosine. Can I make cosine any more basic than cosine? No. I mean, cosine is the same as 1 over secant. But if our most basic functions are cosine and sine, why would you go to secant? So you don't want to do that. So I'm just going to leave this. I'm going to write this as cosine theta. And if it had a denominator, it would be 1, right? Anything has a denominator of 1. So now I'm going to say plus. So let's go to tangent. Look over on our identities. Can I simplify tangent? Okay, there's 2 different things that I can replace tangent with. Which one would be the smarter one to use? Why sine over cosine? Okay, because look, I like that. You're already thinking ahead about canceling. What are our 2 most basic trig functions, did we say? Sine and cosine. So change tangent to sine theta over cosine theta. Some of you are going to get to the point where you don't even have to look at your functions anymore, your identities. You just be like, oh yeah, this is the same. All right, sine. Can I do anything with sine? No, it's pretty basic already, so I'm just going to rewrite this as sine theta over 1. These are being multiplied, right? Okay. Deal. Now, looking at this, can I cross off this cosine with this cosine? No. Why can I not? Because I'm not multiplying. But we're going to get there where we can. Remember, you can't cross cancel through plus signs. But can I multiply? I'm just going to leave this as cosine theta over 1. Can I multiply these 2 fractions together? Yeah. What is x times x? X squared. What's Pablo times Pablo? Pablo squared. What is sine times sine? Sine squared. Agreed? Okay, so this is sine squared theta over, what does the denominator become? Cosine. Good. That's okay. I like that. It becomes COS. Yes, ma'am.
Why would it be sine squared theta and not sine theta squared?
Because you're not squaring the theta, you're squaring the trig function.
Okay.
Good question. All right, so now I have 2 fractions. All right, let's think. Remember, I'm going to constantly say we're going to think algebraically. Let's think algebraically. If I have 1/2 plus 1/3, can I just add those 2 together?
No.
I have to get a common what? Common denominator, okay? So I have 2 fractions here. Can I just add them together? No, I have to get a what? What's my common denominator, guys, between 1 and cosine? Cosine. Agreed. So I'm going to rewrite this. Good job. So look at your first fraction in yellow. The denominator is 1. I want it to be cosine. What do I have to multiply it by? Cosine. So if I do that on the bottom, then I do it where? On the top. So what's cosine times cosine? Cosine squared theta. Perfect. Plus, on the other side, I already have a cosine. So do I have to do anything to it? No. Sine squared. So now some of you are like, okay, I don't feel like this is simplified. It feels like it got bigger. right? Do we kind of feel that way? Okay, I understand that. Have we done anything with this? Have we? Okay, good. That's all right. No, you're fine. I just want to make sure you guys are with me. We added it here, right? We were here, and then okay. So I'm in my most basic form because I have sines and cosines, but now I have some stuff that's squared. So where should my eyes go? The sheet with the formulas on it. Where should my eyes on the sheet with the formulas? Where should my eyes go to? You're gonna get that sheet, I promise. What do you guys notice? The first one. The first one says sine squared plus cosine squared. Well, my thing says cosine plus sine. Is that the same thing? Yeah. What is the value of cosine squared plus sine squared? I can replace this whole top with what number? 1 over cosine theta. Now that looks pretty simplified to me, but I can actually rewrite that so it's not a fraction. What is 1 over cosine the same as? 1 over cosine is the same as secant theta. And that is simplified. So you guys just took what's here in blue, and these two things mean the exact same thing. Cosine theta plus tangent theta sine theta is the exact same thing as secant theta. The work here that is involved is all that I would need to see. Are you guys ready to go and do this all by yourself? Absolutely not. Absolutely not. Yes, ma'am. If you left it, say this was a 10-point question, you left it as 1 over cosine, you'd get some points off because it's not as basic as it can be. That's why simplifying to me is harder, because it's hard to know when to stop. You guys are always going to be like, how do I know when I'm done? I mean, you guys are not ready. I know you're not ready. Just be like, okay, there you go. There's one example. Watch it. The more we practice this, the easier it will get. I promise. You'll start to see repetition. You'll start to see, oh, when this occurs, this is what I do. Okay? So let's scoot along. Again, now we're going to talk about proving. Again, I told you, I think proving is a little easier because it kind of gives you a direction of where you're going. When we look at proving, all right, you want to start with just one side. If you try, and again, you'll see in a second, if you try to do too much at one time, you guys will get yourself so confused. So you want to start with one side at a time. Every time I start a problem, especially when I'm doing an answer key or something, I look and I say, which side looks harder? The side that looks more difficult is the side I want to break down and make it easier. The second step, it says use known identities. You want to use algebra skills. If you have a denominator that you want to get rid of, you can multiply by the conjugate. We'll talk about that in a minute. Sometimes you can do that and it'll create its own identity. But what are the most basic trig functions that we can think of? Sine and cosine. So always think in terms of sine and cosine. If you guys sit there and you just get stuck, look at your identity sheet and say, can I change this somehow into sine and cosine? Just a piece of it. But you always need to try something. Don't just be like, I can't do it. Just try something. Even if you try something and it ends up being a dead end, it gives you some bit of information. So let's look. This is what a proving one looks like, okay? Do you guys see right here? You have a statement. You have an algebraic statement. It says that this left-hand side equals the right-hand side, correct? They're telling you that cosine theta times secant theta minus cosine theta is the same thing as sine squared theta. So the first thing you're going to do is say, okay, which side looks more difficult? Obviously the left one. So I'm going to rewrite this just so I have a little more room. Secant theta minus cosine theta equals sine squared theta. So at the end, what your answer is going to look like is the left-hand side should equal the right-hand side in a statement, in an equality statement. So we'll talk about that in a second. So let's leave the right-hand side alone. But I have an idea of where I'm trying to go. So let's start over here. Again, your trig identities right next to you to work along. Cosine, can I make that any more basic? Nah, so I'm just going to rewrite it. I'm going to rewrite this as cosine theta, and I'm going to put it over 1 just in case I have fractions come up. So now inside secant. Well, let's look at secant. It's not squared or anything, so it's not attached to a 1, so it's not a Pythagorean identity. So look at our reciprocals. What is secant the same as? 1 over cosine. Okay, that makes sense. So I'm going to just change secant to 1 over cosine theta minus, I'm just going to leave cosine. It's cool. Cosine theta over 1. Guys, can I just cross those cosines out? No. If they were multiplied, could I?
Yeah.
Yes, but they're not, so I can't. Deal? You guys understand?
Yeah.
All right, leave that cosine hanging out outside here. Cosine theta. I have two fractions. Think about algebra. 1/2 plus 1/2 minus 1/3. I have two fractions that don't have the same denominator. What should I do? Get a common denominator. What would be a common denominator, my friends, between cosine and 1? Cosine. Perfect. So look what we have here. The first fraction has cosine already. So what's in the numerator? 1. Agreed? My second fraction doesn't have the cosine in the denominator. So I'm going to multiply the bottom. What I do to the bottom, I do where? To the top. Okay, guys, what's cosine times cosine? Cosine squared. Same as Pablo times Pablo was Pablo squared, right? Before we had sine times sine was sine squared. Now we have cosine times cosine. Same concept. Now, at this point, you can do a couple things. Do you notice how you have a fraction times a fraction? If I had 4 over 2 times x over 4, what could I do to the 4's? I could cancel them out. Do you have a cosine in a numerator and a cosine in a denominator that are not attached with a plus or minus? So, boom, cross those out. What are y'all left with? 1 minus cosine squared theta. Now, what are we trying to prove? That the left-hand side equals the right-hand side. We're trying to prove that 1 minus cosine squared theta is the same as sine squared theta. Well, I have a 1 and a minus sign and something squared. So where should my eyes go? To your Pythagorean. Do you see any Pythagorean identity that has a cosine squared in it and a 1?
Yes.
This one, right? The first one?
Yeah.
All right, so it's not exactly what we need it to be, but this one says sine squared theta plus cosine squared theta equals 1. I want the blue to look exactly like the yellow. I do what? Not add it. What will we do to the blue one? Arthesia, what do we do? I'm going to subtract. Look what happens if I subtract cosine of theta. What does 1 minus cosine theta equal? Yep. Sine squared theta equals sine squared theta. Isn't that what we wanted it to say from the beginning?
Yeah.
So you guys just proved it. Now, some of you, guys, this is my 18th year teaching, right? I didn't start yesterday. So I know what'll happen. Because someone last period was like, oh, so that's your answer? Sine squared theta equals sine squared theta? No. Guys, that I gave you the answer at the beginning. Your answer is all of this junk in here. Right? So when you, hold on one sec. When you guys answer this problem, when I go to check, I'm going to check each step. Every single semester, someone goes through and they just write all kinds of random identities from the sheet that I give you. And then at the end write sine squared equals sine squared. If it doesn't make logical mathematical sense, you're not going to get credit for just writing this last statement. Does everybody understand that? Yeah. This has to follow mathematical thinking, which is we are going to get better at. You guys are doing a great job. I know this seems like a lot, but you're doing a great job. Yes, sir.
Can you go back to
Here?
Yeah.
Okay. So this is a fraction times a fraction, right?
Yeah.
So if I have the same numerator, if I have a numerator on top and a denominator on the bottom that are exactly the same, we can cancel them out.
Mm-hmm.
That's just what I did there.
Yeah, I just got lost when you.
Okay. So now I'm left with 1 minus cosine, right?
Yeah.
So then I look over here and I say, okay, well, what can I do with that? And I know I'm trying to get to sine squared. Because at the beginning, that's what they told me. I wanted the left-hand side to equal the right-hand side. So I looked and I said, okay, I have a cosine squared and I have a 1. So on my Pythagorean identities, because I have 1 and something squared, is there something that has cosine and 1 in it? And yes, this top identity does. So when you write it down, which is what I did here in the blue, this part, when you write it down, sine squared theta plus cosine squared theta equals 1. Agreed? And I wanted to manipulate that so it looked like this. So do you agree with me that if I subtract cosine from both sides, my handwriting was decent, 1 minus cosine squared theta. This cancels out, so I'm left with sine squared theta equals 1 minus cosine squared, which is what we wanted it to say at the beginning. So we proved it. Algebraically, we took the steps to manipulate that left-hand side, cosine theta times secant theta minus cosine theta. We took all those steps in our identities to prove that the left-hand side is equivalent to the right-hand side. Let's do another one. We'll do one more. Okay, here we go. All right, this is a more difficult problem. The other one just had one term on the right-hand side that said, hey, make the left side look like the right-hand side. We'll do this one, and then we'll be done. All right, so I'm going to rewrite this. I'm going to say cosine, we can use x, over 1 minus sine of x. If you want to leave it as u, leave it as u. It doesn't matter. Equals secant x plus tangent x, right? We want one side to equal the other side. They're telling us already that it does. But at the end, your left-hand side should look exactly like the right, or the right-hand side should look exactly like the left. So let's look at this. Which side looks more difficult? Why the left? I agree. How come? Because there's a fraction. Right? We start off with a fraction. It's like, ew, get rid of it. So let's just ignore the right-hand side for a minute. All right, we can keep coming back to it to kind of give us some direction, but let's just ignore the right-hand side for a minute. I'm going to look over here, and I'm going to say, all right, I have 1 minus sine squared, 1 minus sine x. If it was 1 minus sine squared, we could look at our Pythagorean identity and be like, oh, I can change that to cosine, whatever. That's not the case. But can I do something to create a Pythagorean identity? A lot of times this will happen if you have a trig function that's attached to a 1 in the denominator, but it's not squared. If I had 6 minus 2i in a denominator, and I wanted to get rid of the i's in the denominator, what would I multiply the bottom and the top by? Not just I. You guys remember? How did we get this to go away? How do we get the i's to cancel out? What's the opposite of 6 minus 2i? Remember, we multiplied by the conjugate, and then when we FOILed it out, it's the difference of perfect squares, so the i's would cancel. Same concept here. Whenever you start off with a denominator that has 1 minus or 1 plus, and the trig function is to the first power. If this was squared, it's a different story, but it's not. Multiply by the conjugate, and you'll see why in a second. What is the opposite of 1 minus sine squared? 1 plus, or sine, I'm sorry. We're going to create sine squared. That's why I keep saying that. All right, so just leave your numerator alone. Just don't worry about multiplying all of this together. Just leave it. Because we're simplifying, remember? So this is going to work itself out. Just stick it together. You don't actually have to multiply cosine. But if I FOIL the bottom, what is 1 times 1? 1. What's 1 times negative sine? Negative, good, sine of x. What's positive sine times 1? Positive sine x. And what's sine times sine?
Sine squared.
Yep, so minus sine squared x. What can I simplify? I can cancel out a negative sign and a positive sign, correct? Okay, that cancels out. So I have on the top 1 plus sine x over cosine x over, what's left on the bottom? 1 minus sine squared x. Okay, now we're trying to get to secant x plus tangent x. Does it even look like we're close?
No.
No. Does it look like we've made anything any simpler? Ish, kind of. I know some of you are like, what are you doing? I get it. I get it. I get it. I get it. When you FOIL this out, positive sign and negative sign, what's a positive times a negative? It's a negative. Now, let's think about it for a second. All right? I can't do anything with the top. It's still going to just be this 1 plus right now because nothing else is going to simplify. But on the bottom, guys, I have a sine squared and I have a 1. Is there a Pythagorean identity that has a sine squared and a 1 with it? The first one. You're going to refer to that first one a whole lot, guys. I have 1 minus sine squared. 1 minus sine squared. So my first identity is sine squared plus cosine squared equals 1, right? I want it to say 1 minus sine squared. What could I do? I can subtract sine squared. What does 1 minus sine squared equal? Cosine squared. Good. I can replace this with just cosine squared. I get it, guys. This is like, what? I get it. I get it. I get it. We're going to practice this a whole bunch. But have I made my denominator simpler now? One sec. Have I made my denominator simpler? Yeah, I had 2 terms before, right? I had a 1 and a minus, and now I only have how many terms? I only have 1. It's not separated by a plus or minus sign. Kira?
Can you move that last part to the white? Because I can't see it.
Now think about this, guys. Look, I have a cosine on the top, and I have how many cosines on the bottom? 2. Can I cross one of them off? Yeah, because they're not attached to plus or minus signs. So I can say that this cancels, and this becomes just 1 cosine x, right? Okay. So I'm still trying to get here. Sarah, question?
Yeah, but I'll just let you finish.
Okay. All right, so now we're like, oh, geez, where do I go from here? Okay, so when we have situations like this, guys, notice what you have. How many terms are in your numerator? How many terms? Terms are separated by plus and minus signs. How many terms are in your numerator? 2. And how many are in your denominator? 1. Okay, we've seen cases like this before. 3 plus square root of 2 over 4. How can I rewrite that? Can I separate it? To what? 3 over 4 plus what? Square root of 2 over 4? You guys agree? Right? 2 terms in the top, I can separate it. So can I do the same thing here? Just because it's not numbers, that's okay. We're going to think algebraically. We're going to work trigonometrically, but we're going to think algebraically. Can I separate this into 1 over cosine x plus sine x over cosine x? Absolutely. And again, this is new, so you guys will see this. We'll start developing the pattern of, oh, if I only have 1 term in the bottom, I can separate it. So now let's see, because remember, we're trying to get to this. We're actually getting closer. Because if I look at my identities, what is 1 over cosine the same as? Secant. Agreed? So this is the same as this. And then if I look at my identities, what is sine over cosine the same as? What am I trying to get to? Look, secant x plus tangent x. What am I trying to get to? Secant x plus tangent x. You guys just proved it. You just proved that these two are the same. All right, again, guys, it's a lot. I know it's a lot. You're going to get to stuff and be like, oh, how did you know to do that? And it's just a matter of working these out and then working them out again and then doing a different problem. We're going to do a bunch of these. Your homework tonight is not due tomorrow until the end of the class period. I am going to go through all of them with you. So if you want to give it a shot, just look at it and try. See if you can simplify some of them. See if you could just work through it. But tomorrow in class, we're going to do this together. I'm going to do it with you. So then at the end of the class period, you can just submit your homework or your notes, whatever, and that'll be a homework assignment. And then you guys will have some practice for the weekend. But again, we're going to practice this a whole bunch. I know this is hard. It's a little overwhelming. I get it. You okay? Kind of? Sarah, did you want to ask me anything?